Unit 2A, Lesson 3. This lesson will align with 8.5 and 8.6 in your textbooks. Two standards we are going to cover in this lesson. The first one, proof theorems about triangles. Theorems include a line parallel to one side of a triangle divides the other two proportionally and conversely, and the Pythagorean theorem proved using triangle similarity. Second standard, use congruence and similarity criteria for triangles to solve problems and to prove relationships in geometric figures. The first theorem we are going to discuss is the triangle proportionality theorem. This theorem says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so we have line segment TU parallel to line segment QS of this triangle. So if this is true, according to this theorem, we have the statement down below that is true. If TU is parallel to QS, then RT over TQ is equal to RU over US. So RT over TQ is going to be equal to RU over US. This is called the triangle proportionality theorem. In this first example, we're going to use ideas of similarity to solve for the missing angle. We're told that triangle ABC is similar to triangle XZY. Okay. Remember when we talked about similarity, the order in which the vertices are labeled matters. This means vertex X corresponds to A, Z corresponds to B, and Y corresponds to C. So using this information, this similarity statement, we know the value of angle Y is 67, which means Y corresponds to C, so the value of angle C is also 67 degrees. So without using any algebra, any equations, we can determine what the value of the measure of angle C is. We could also determine what the value of angle A is. Okay, remember the triangle sum theorem says all three interior angles must add up to 180 degrees. So if we would take 180 degrees minus the sum of 62 degrees plus 67 degrees, that would be equal to 51 degrees. So that would be the value of the measure of angle A. Next, we are going to talk about the sum of the interior angles of a convex polygon. If we take n minus 2 times 180 degrees, that's going to give us the total sum for all of the interior angles of a convex polygon, where n stands for the number of sides of the polygon. In this example, we're told that pentagon GHIJK is similar to pentagon BAEDC. We want to determine what the measure of angle D, the measure of angle E, and the measure of angle C are. First, we should focus on this first pentagon because we know 4 of the interior angles. According to what we just talked about, that formula in the last slide, we should be able to find the measure of this missing angle. Okay, because this is a convex pentagon, if we take the number of sides, which is 5, minus 2, and multiply that by 180 degrees, that will give us the total value of the sum of the interior angles of that pentagon, which is going to be 540 degrees. So now we can take 540 degrees and minus the sum of the other 4 interior angles added together. So we have 94 plus 137 plus 76 plus 107. And that's going to be equal to 126 degrees. So that's the value for angle H. Now we're going to go back using this similarity statement. If we're looking for angle D, D corresponds to angle J. So the measure of angle D is going to be equal to the measure of angle J, which is 76 degrees. Now if we want to find the measure of angle E, E corresponds to I, so that will be 107 degrees. And the measure of angle C is going to correspond to the measure of angle K, which is 137 degrees. So we actually didn't even need to find the measure of angle H to find these three missing angles we were looking for, but it's good practice using that formula, finding the total sum of the interior angles of a convex polygon. In this next example, we're told that quadrilateral UVWX is similar to quadrilateral FEDG. We want to find side lengths UX and EF. Alright, so we need to find what the ratio of the comparison of the side lengths are. Basically, we're finding the scale factor. So we can compare VW to ED because those are corresponding sides. So if we compare WV to DE, put those side lengths in, 24 compared to 3 simplifies to 8. So the ratio of the side lengths is going to be equal to 8. Now we're looking for the length of UX. Well, using some logic here, we know UX corresponds to FG. FG is a length of 3, so if we take 3 times 8, the length of UX is going to be equal to 24. Since ED and FG are the same length, they're both 3, WV and UX must be the same length as well, so they will be 24. Now we want to find the length of EF. EF corresponds to VU. So VU is a value of 16. So 16 over EF, what we're looking for, is going to be equal to, now we need to use this ratio we came up with, the scale factor before, which was a value of 8, which is the same as 8 over 1. So we can create a proportion. So we have 16 over EF is equal to 8 over 1. If we cross multiply, we get 16 is equal to 8 times EF. And now if we divide by 8, we get the length of EF is equal to 2. So using some logic, we found UX is equal to 24. Then using some geometry, creating a proportion, and then algebra to solve that, we know the length of EF is equal to 2. To end this lesson, we're going to go through a proof of the Pythagorean theorem using similarity method. There's many different proofs you can go through to prove why the Pythagorean theorem is true. Since we've been talking about similarity, we're going to use similar triangles to do this. Okay? Pythagorean theorem only applies to right triangles, so that's what we're going to be working with in this example. So if we start with triangle ABC, okay, then we have side lengths, little a, little b, and little c as well. What I'm going to do next is draw in the altitude. The altitude goes from vertex perpendicular to the opposite side, which we can see here. We go from vertex C to the opposite side. That's called the altitude. Alright? Now that I have this constructed, you can see that we have 3 different triangles. We have the 2 smaller triangles and then still the larger triangle. For the length of the altitude, I just labeled that H. And now that we broke this side C into 2 different parts, the shorter part I'm going to label as X, and the longer portion label as Y. Alright? Now down below, to make this easier to work with, I'm going to take this red triangle that we created and rotate it so that it lines up nicely with our right angle in the bottom left corner. Same thing with the smaller blue triangle. Going to rotate it so that our right angle is in the bottom left corner. And then we still have our larger triangle that we started with, triangle ABC. Since we constructed the altitude of the right triangle, this creates 3 right triangles, triangle ACD, triangle CBD, and triangle ABC, these three right triangles are all similar to each other. So since these are similar, we're going to be able to create some proportions that we can solve, then use some algebra to rearrange them in order to come up with the Pythagorean theorem. First, I'm going to compare triangle ACD to triangle ABC. So if I take x over b, so I take the ratio of the shorter leg to the hypotenuse, that will be equal to the ratio of b to c. So this will be equal to b over c, which if we cross multiply, we take x times c, and that will be equal to b times b is b squared. Now I'm going to compare triangle CBD to triangle ABC. So if I take a over y and set that equal to c over a, again going to cross multiply to solve this proportion, y times c is just yc, equal to a times a is a squared. So we have two different equations. Xc is equal to b squared, yc is equal to a squared. I'm going to combine these two equations. Since they're equal, I can add the left sides of the equation together and add the right side of the equations together. So I'm going to combine these two equations into one down below. So I'm going to take xc plus yc and set that equal to a squared plus b squared. Using a little algebra here, looking at the left side, they have a factor of c in common. So I'm going to factor c out in front, which leaves us with x plus y equal to a squared plus b squared. Now we can simplify x plus y. If we go back to the top where we started, when I drew in this altitude, I created these two smaller segments, but we know if we take x plus y, that's equal to this whole side length, which is c. So back down below, x plus y, this is equal to c. So I'm taking c times c, setting that equal to a squared plus b squared, when we know c times c is c squared. So c squared is equal to a squared plus b squared, and you should recognize that is the Pythagorean theorem. So using similar right triangles, we can use ideas of proportion, similarity statements, and simplify to come up with the Pythagorean theorem. That concludes this lesson. Make sure you have questions ready over any vocabulary terms or any of the examples. I would recommend going back through this proof again. That way you have a better understanding of it when we discuss it in class.